And how we all doing out there? Everybody in a food coma, I hope? My name is Chuck Hixon, and I'm with Bergman Associates, and along with Kevin Gilson, we'll be talking about digital cities today. And we'll start off with a high-level approach to what we see happening out there with cities, and hopefully that'll translate over into transportation agencies over the next year or so. But we like to challenge you, and we also would like to make this a little more interactive than just us talking. So as you have questions, we'd like to have them. So don't be shy. Raise your hand. And again, I'm Chuck Hixon. I've been with Bergman Associates for 21 years. I have a lot of gray hair in my head, and I guess the best analogy I can give for you is back in 1983, I worked for Intergraph Corporation, and I was the guy rolling these huge CAD machines into the drafting rooms and taking the drafting tables out. And that was a pretty trying, stressful, expensive time. All the same questions we have today and that have been brought up quite a lot are the same questions that were back in 1983. No standards, no guidelines, very expensive. How do we implement? But here we are 30 years later, and we're at that same evolution again. And that's kind of the reoccurring theme that you'll hear from Kevin and I. As much as things change, sometimes they stay the same. So, Kevin, if you want to just tell about your dazzling self as well.
Green. Yeah, hello, I'm Kevin Gilson. I manage the design visualization group at Parsons Brinkerhoff, which is a large transportation engineering firm. We've had a visualization group since '92, started by a gentleman named Doug Eberhard. I joined in 2000, but I've been doing this since I graduated from college in somewhere around '83 as well. So I agree, there have been threads that are the same throughout that entire time. ROI, how to get clients to pay for it, you know, what is it we're really trying to accomplish, that sort of thing. So
without further ado, we'll just start getting into it. And again, please ask questions as we go. The first trend that's already happening out there is smart cities, digital cities. They're out there. These cities are trying to deal with all sorts of data that's being thrust upon them, whether it's municipal data, traffic data, GIS data, a myriad of information, and how are they managing that information. You see two URLs up there to kind of give you an idea where some entities are heading. The top one is Smart Cities Initiative in Europe, where several cities are collaborating together to standardize the data that they have, to pool resources so they can understand that data better, and also to be more macroscopic, to share that data between them as well. The bottom URL is from Australia and New Zealand, which are collaborating on a countrywide basis to do the same type of thing. The presentation earlier today had talked about silos of data. We have all this great information, but yet how do you access it? And I think, in my opinion, that's the hurdle that needs to be crossed. How does everyone use this data? I pick on the GIS community a lot because they're like a cult. They're very, very passionate about their craft, very dedicated, and they're all about data. And they figured out over 20 years ago that data needed to be graphical. And they themselves are in the process of migrating to a three-dimensional database-driven world. But they've always kept that data within themselves, and today lots of people need that data. And that's the real challenge for all of us. How do we get all that information to the people that need it and want to use it? And we'll explain a lot of that as we go as well. So I'm just going to start showing out what are some of the drivers that are happening out there for cities to deal with. And these are all things you've heard probably ad nauseum. I like to pick on cloud computing. Everybody thinks the cloud is this amazing thing, but again, I'm old. Back in 1983, we had the cloud. It was called the mainframe, and you had some dumb terminals hooked up to the mainframe. It was a cloud back then too. Bill Gates came around and said, you know, having dumb terminals hooked to a mainframe is pretty stupid, so let's make intelligent workstations. And here we are going back to the future again with dumb terminals such as a mobile device or a pad hooked up to some sort of cloud-based device. But again, a legitimate push out there that we're seeing. Mobile, a really, really big push. The generation X and next have grown up in a mobile world. They want information, they want it now, and they want it wherever they are. We need to address that environment as well. Certainly a generational type of thing. And other trends up there, and one that we're all dealing with right now, I know we are, is laser scanning. You hear all the time how amazing a laser scan is. I can scan your building in one day. And maybe you can scan that building in one day, but then what are you doing with that information? How are you using it? Or if I'm the IT director, where are you storing all that data? So lots of issues in itself right there. And another one to pay attention to, I think, is crowdsourcing, you know, which is like a Wikipedia or what used to be a Google Earth with all of their 3D libraries as well, where people are providing information to a common source. So all trends that are pushing the need for these digital cities or soon these digital agencies that we're to have as well. You heard earlier talking about civil integrated management and the FHWA's push to create a life cycle process for all sorts of data, whether it's CAD data, GIS, or whatever, and all of these things envelop into that whole SIM process where we're becoming more of an enterprise solution, or as I like to say, more of a macroscopic approach to things. And again, going back, if a CAD operator was doing his portion of a project, he was focused on a very finite portion of something to provide that information. And a lot of times we need to look at the big picture as well to really understand what's going on. So trends. And this slide is a lot of fun, but it's a lot of truth for all of us out there. This is the classic technology trend. Are you an early adopter, an innovator, or are you a laggard? And where do you fit in this 3D digital world? Because you need to fit in it. Just like CAD back in '83, you had to figure out where on that curve you were going to invest in CAD. Well, the same holds true for our digital city world. Find out where you want to be. Do you want to be an early innovator and then have to write a lot of custom code to figure things out? Or do you want to be a laggard and not innovative on the one side and miss out on opportunity? You have to decide where you fit on that curve. I had mentioned civil integrated management. We'll spend just a few minutes. And the everyday counts URL is in the corner, and I recommend anyone go visit that site, not only for civil integrated management, for any type of innovative technology in the transportation industry. But essentially, SIM is a life cycle process where we're trying to think beyond our own discipline and wrap it into everyone's discipline. I'm not an architect or an engineer, but typically what I see is we have a planning process. Something is produced from that plan, and if the project pushes forward, we go into preliminary design, and we typically throw out everything we did in the planning phase and then do it in the preliminary design phase, and vice versa into the design phase and ultimately in construction phase. There's a lot of inefficiency because we seem to be redoing things or recreating information, and if we thought more on a life cycle or macroscopic approach, we should be exploiting the information that's done in the planning stages well into construction and operations and management. And ultimately, I think the reality out there is funding will continue to be limited. And unless we change the way we generate funding, we're going to have less funding. So how do we do the same or more with less funding? And I think the big driver is we need to think and operate more efficiently. And one of the major caveats of all of this technology is just that. If, for example, we can exploit the information created in the planning stage for the design phase, we save monies, and that allows us to achieve. So a big portion of that, and I think ultimately to me that's what's going to drive everything is money. CAD, why did back in 1983 someone spend $40,000 on a workstation, $500,000 on a mainframe, and another $20,000 for CAD? That's an awful lot of money to do drawings, but there was a reason behind it, a driver. And we're at that same phase, and I know Kevin, as well as I, we get that asked a lot. What is the return on investment in this technology, or what are the savings? And that's a frustrating portion for us because we don't have those empirical data to give to you on the savings. We have many, many implied stories of how this saves. But that's something I challenge to everyone out there to continue to find those type of sources of information where we do see those savings. I don't jump in if you want to add on to that. But again, I had mentioned a life cycle process, and that's what these digital city type of approaches. We got to think and repurpose, reuse, and get out of our singular thought process where we're sharing information better. So we need that data so that we can share that data with someone else. And again, I'll pick on the GIS folks again. Typically, they're in the planning groups of a city, for example, and they produce some outstanding content. How does that content get to the EMS group or to the mayor in a way that's easy for them to get that information? And to me, that's a big hurdle or wall that needs to be crossed. How do they get that information that's produced? Great information, but how do they get to it? And with a life cycle approach, I think we can achieve a lot of that. This is a good slide to kind of explain, again, from a planning process, how do we get to approvals? Again, if I have a more efficient process in place, I can create efficiencies for the approval process, either reducing the effort to really assess and design something. An example would be we're working with the city right now to implement all of their zoning and permit codes into a GIS application called CityEngine. And then what we hope to do with CityEngine is get files from a designer, for example, using Revit, and put that Revit model into that CityEngine program to do all of the zoning and checking automatically. So we don't have to spend time or waste time finding that information. It's more rapid, it allows quicker approvals, and obviously reduces costs. So some of the general benefits of the technology. Obviously, again, if I'm thinking from a big picture, master planning is an incredible tool for many different reasons. One is it's more of an interactive and interpretive program. Einstein said if I can visualize it, I can understand it. And this certainly is the case during the planning process. If I have the ability to combine data into one source, one centric database in a 3D world, a visual world, I can understand it better and I can plan better. And obviously, I'm not going to go through each one of those, but you get the idea of some of the benefits with the technology. As you go through these benefits, I want you to realize, too, that there's multi-purposes behind it. We're not just designing. We're not just planning. There's other things and avenues that you can pursue with all this technology. In this case, this slide focuses on revitalization and reinvestment. If I have, for example, a master 3D database of my city, I can use that database for multiple reasons. In this case, for revitalization. Generating interest, outreach to the community. All things that cities are looking hard at right now. As I had mentioned before, the approval process, I think, is a tremendous place to save monies, to allow us to do things with the same amount or even maybe less. All this technology, again, folds upon itself. And if we go past the planning, design, construction, let's go into operations and monitoring. Again, dynamic sign messaging. You see here, I think all sorts of good data can be reused once again. to allow us to become more efficient, and again, in this case, helping to move traffic. Maybe making a decision that we don't have to necessarily build another lane of roadway. We can repurpose that roadway through some good analysis as well. I only have a couple of slides left, and then I have more of an interactive presentation, but this is kind of where we were, and I'll show you where we're kind of heading. Somebody earlier had mentioned about utilities and the identification of where they're at, and I do a lot of work for college and universities, and it's certainly a spaghetti bowl of utilities under most campuses. It's probably the #1 issue they have with where the heck are those utilities. And most campuses use GIS, and what you're looking at is a typical output from 2D GIS. What we want to do is we want to go into a 3D GIS world where we have things in 3 dimensions, and then I can interact with it, where I can turn off the terrain and see the utilities underneath the ground. But do more than that, I can identify things with it since it is a database, and so I can get information. And what I'm going to do is I'm going to jump out of here and do one demo for you real quick, kind of showing you that instead of in a slide portion. But before I go into the interactive portion, are there any questions we can answer? Yeah.
This is a dumb question, but start from the beginning. How do you collect this information that allow you to depict the city? Does somebody have to sit there and take the pictures and?
Great question, and you couldn't have been planted into my demo any better. So as I go through this demo, I'm going to describe at least how this project is created. And one thing both Kevin and I want to stress to you is that we're not a proponent of one piece of software or a process. They all can work. It's what you have and how you want to manipulate that information. And again, we're not talking about software here. We're talking about a process. When I mentioned CAD. CAD can be anything, an Autodesk product, or it could be a Bentley product, or whatever product you're using. And, that's kind of our approach. But there's a lot of great information out there that you can use with your tools. And I'm going to start off, in this particular case, with Esri's ArcGlobe product, is how we created this world. And this is the campus of the University of Rochester, and I'm going to kind of zoom out a little bit. And it's running inside of Esri's ArcGlobe program, but you can get it to run in other programs, which I'll show you as well. So how do you create these environments? I think there's so much assets out there that are available to you to start these. For example, the terrain is from LiDAR. The aerial image, the university flown, but for example, in Pennsylvania, they have the PASTA website, and all of Pennsylvania has been flown LiDAR-based. So, and you have access to that information. You have access to the aerial imagery as well. Most states have GIS clearinghouses with information as well, aerial imagery, terrain, so forth. Those are the places you can start, and in a lot of cases, the information's free. So you can start, and it'll be at various levels of fidelity, but free nonetheless. In this case, the university wanted really tight aerial imagery, so they flew it, and it's 4-inch aerials for that. So that's kind of how we make things. We get the LiDAR information, we convert that into a terrain model. We take the aerial imagery, and then we drape it on top of that terrain model. In the case of this campus, we're at 1 foot contour for the terrain, just to give you an idea of the fidelity of the terrain. From there, say you want these buildings for your city or your environment. There's many different places you can go to get those buildings generated from aerial imagery. For example, pictometry is a source you can use. We use a firm in California called CyberCity 3D, a fantastic firm that can generate the 3D models of, for example, a square kilometer based off of aerial imagery. And the geometry is pretty tight. It's not super accurate, but in most cases, accurate enough for us. And they can do that relatively inexpensively. For less than $5,000, you can generate a square kilometer of area with the structures. So the investment is not as bad as you might think it would be. And I'll show you other examples of that as well. So we have this virtual world that we can go around and interact with. What else can we do with it? Well, if we have GIS information ahead of time, we might be able to exploit and reuse that. In the case of the university, they had a tree planting database. They knew where all the trees were on the campus, so we could roll that information into our geospatial and georeferenced environment that we created. And that's a fancy way of saying that all the buildings and so forth are actually at their world coordinates. So it's a pretty accurate system as well. So what do we want to do? And besides just moving around like in a video game, we want to use data and we want to see it in a 3D context for reasons I'll explain to you for savings. And let's go back to that utility mess I explained earlier that most campuses have, and the University of Rochester is no different. They have what almost every university has, is the Indiana Jones room, I call it. That's the room where all the flat files exist, all the whatever backups they have, all in this room that one guy that's been there for 40 years knows where stuff is. And if I asked you to find me a file for this particular pipe and send you in the room, hopefully you'd come back out of that room. So a very inefficient way of storing information, but more importantly, accessing information. So I'll give you a brief demo of how that can be resolved. One way is, as I had showed you in the slide, here's one section of the campus, and I can turn off the terrain, and we can look under that terrain to see the utilities that happen to be under the ground. But since we're in a database that just happens to be in 3D, we can actually do things with it. I can select a pipe, and it can tell me that's the chilled water supply line. But if we go further down into the attribute table, I can actually select that file from the database now and call it up. And this particular case, I know this is probably a shocking revelation to most of you, but they actually designed stuff before computers. In this case, this is a file from 1969. So if I had to send you into the Indiana Jones room to find that file, I don't know how long it would take you. Say you were really good, it only took you half an hour to find it. Here, you find it in seconds. But more importantly, if I'm somebody that doesn't know a thing about that room, I can click on something visual and get it. So it's, again, providing information in an easier context for people to access so they can make decisions. Other examples, just to show you real quick. Let me just, you don't have to think external either. You can think internal. Oops, let me get out of here for a minute. This is Lattimore Hall, and the same type of thing. Again, I can click on a tree. It tells me that's an oak. I'm not linked to their database, so I can't tell you the last time that tree was maintained or the thickness of the trunk or who planted it. But that kind of information is available to them. The process here, and we're using Esri's product because that's what the campus had. They have GIS, and instead of making them buy new software or yet another database, let's just have them repurpose what they already have. But what we want to do is we want to tie all sorts of data into it. So that tree inventory came from another database, or in the case of the building here, whoops, hang on a minute, let me get back in. Hopefully I can tag the structure. There we go. We got Lattimore Hall, and then what about Lattimore Hall? We can actually drill down in this particular data and go floor by floor if we want. And again, I'm only showing you the PDF. I'm not attached to the database in real time, but I can get CAD information graphically. I might not be a CAD specialist. I might not even be a GIS specialist, but I can certainly get to information as well. But what I really like is let's tie that information to something else. In this case, they use Maximo for space planning. So here's Maximo data, the green indicates rooms that are not in use in that particular building. And again, I'm not an expert. I don't know how to use Maximo, but this system knows how to go out there and pull that information in for me. Again, it's about getting data into a centric location that you can use, but you don't have to be a programming expert to use the data you want. And I got hundreds of more examples in here, but I'll kind of start repeating myself if I show this over and over again. So let me challenge you one more time. This is using ArcGlobe, which is a fantastic program, especially if you're a GIS person, because you need that software loaded on your computer to run it. You probably need to be trained on it. What happens if you don't have that software? How do I access that information? There's several ways to do it. One way is to take all of that information and take what I'll call a 3D GIS snapshot in time, and then import that into a gaming application. In this case, I'm going to call up Unity, which is a popular gaming tool used by most game developers. And I always tell the story of the thumb people out there. I don't know, does anybody have met a thumb person out there? Well, let me introduce you to a thumb person. I did well, actually, I was with my son touring college campuses, and we were in the mechanical electrical class, and the professor made all the students leave the room, and he asked one question of all the parents. And the question was, you're in an elevator, you're on the 8th floor. How do you get to the 8th floor? And so I know I can ask all of you, how do you get to the 8th floor? So somebody show me how you get to the 8th floor. Who's going to be, there you go. Give that man $1 back there. He pointed. That's what you do. You point and you go to the 8th floor. So he made the students come back in the room and he asked the same questions. And 90% of the students did this. They pushed the button with their thumb. And that was his point, is you need to think differently for this next generation. You need to design differently because they're thinking differently. They grew up on their phones or little iPads or Nintendos. So think like a thumb person. All of this technology is addressing how they have grown up. Instant information in real time. So we need to think. That generation is going to be pushing our wheelchairs soon enough. Right, Terry? I'm pretty sure. So this is the same model of the campus. It just so happens to be in Unity now. And allows us to do all the same things that we did or in the GIS database. The difference here is we're just mimicking the data. We're not actually linked to it. We're not doing any assessment with it. We're just playing back what we've already done. But what it does allow me is I can give this and distribute this to anyone. I can put it on a website. I can put it on a notebook, a pad, a phone, so that other people can see the information that I produced. And then, so if I don't have any kind of GIS experience, I can still do some GIS analysis, and I'll show you an example over here where the university is in conflict with the local utility about putting a substation in. So we overlay the substation, which is, again, we're in a georeferenced, geospatial world, so when we bring that CAD data in, it's going to lay in where it should be. It's true to scale, so we get a nice assessment of what that substation looks like. But some of the amazing tools that are provided in a GIS world is to do viewshed analysis. Where do I see these types of things? So again, I didn't do the assessment in this package, but I can see the results that were done in GIS. So everywhere in yellow is where the impact of that substation will be. And if you look, there's some buildings that really get impact, but not a tremendous amount. But again, we're thinking macroscopic. We're in a big world, but we're thinking beyond today. We're thinking tomorrow. And if I overlay the campus's master plan on top of this, you can see there's far, far more buildings that are impacted by this substation than previous. Again, big picture, we're getting to see lots of different data at the same time, so we make better decisions. We don't do rework, or in the case of this, the university convinced the utility to bury the substation so that you didn't have to see it. Again, getting tools in front of the people that truly need them, which are decision makers, stakeholders, all of those people. I personally, and I know Kevin's the same way, we don't want to change the way anybody works. We just want to change the way your work is seen and interacted with as well. Oh, I forgot to connect to the network. So I'm going to try one last live demo here. Hopefully it doesn't blow up. Say you're let's see if it works. Okay, I think it's going to work here. Hopefully I'm on the internet. Bear with me. Say you don't have Unity or somebody that knows how to write that code, but you need stuff to be conveyed over the internet. Esri does have let's see if I call up a small one here, a product called CityEngine, which I referenced early. CityEngine is a rules-based program that allows you to, oh shoot, I can't run it in. I'm not connected? What the heck? Oh, hang on a minute. Bear with me. Kevin, talk for a second. Entertain them. Whoa! Hang on a second here. All right.
Before you go on CityEngine, what was the export format you're using for the 3D models in the Unity?
FBX is how I brought in into Unity. The way these environments are created, by the way, to go back to Pat, you could use for existing stuff, we use CyberCity or Pictometry. We can bring in SketchUp files, 3D Studio Mac, Microstation. It doesn't really matter anymore. And that's the real world out there. There's an amalgam of many products that you're using. If you pick a roadway, you're not doing everything in Microstation. You might be using Microstation and some other add-on apps as well. And to me, that's the real power of it. Let's see if I'm hooked up now. Somehow I'm not believing it.
Chuck, I have one more question for you.
Yeah.
A couple years ago, you had that campus in a proprietary game engine.
Mm-hmm.
So you migrated to Unity, and I was just curious, what were some of the reasons you made that decision?
Again, I'm only speaking for Bergman Associates, but I want to use off-the-shelf software that my clients have. I don't want them to have to buy something else and relearn. And that's the feedback I have gotten. I don't want to have to learn anything new. If you're going to throw another software package at me, I don't want it. Or the other reason is, hey, we like you, Bergman, but maybe we're going to go have somebody else work on this project later on, and I have to be able to. Are you
web page.
here? You go ahead. It removes the angst of being stuck with one vendor. So Unity is an off-the-shelf program. Esri's CityEngine is another program that also is fairly open-ended if you have GIS software. And that's what I'm always striving for, trying to find avenues to provide this information in a non-biased context, I guess. We still use the proprietary engine as well, which the University of Buffalo, who was a business partner of Bergman, they wrote that program. It's based on Performer, if you're familiar with Performer as well. Are we good now? Oh, it's HTTPS.
See if you can go down to one of your pages.
Let me just type here and see what the test does. We're in. Why won't it run? Why is it saying unload? Let me try any of them. Didn't like that one. What other questions while this is loading up? It's going to take a few minutes. Well, a minute.
When you deployed your web viewer, was that a clunky process, or how did that? We haven't actually deployed anything of CityEngine yet, but we're working with it. So I'm just curious how that process
Well, if you go back to my, where are you on the technology curve? We're more on the innovator side. CityEngine is in its infantile state. There's a lot of one-off coding we need to do to get it to do what we want. But I know Esri is putting some significant resources in it, and as it goes, it'll be a more mature product. Our client, which in one case was City of Rochester, they wanted it in CityEngine. They needed it web-based utility. They didn't like Unity because they felt it wasn't as easily distributed in the way that they wanted it to be, so CityEngine was the choice for that. CityEngine certainly has some issues importing files that we need to work out, but probably a bigger thing is, since it's a rules-based program and we write the rules, what we want it to do, I can't go to Best Buy right now and get the city zoning code rules to start me off. I have to write them from scratch. But I think over time, the CityEngine community will become more and more robust, where a lot of these rules will be in there. They'll be customizable, but it's a good place to start as well.
When you were showing us the water chill pipe under the ground, we weren't seeing a 3D under the ground because that data didn't exist? Is that?
Yeah, I think most places, and it was brought up well, is most places know where the utilities sort of are, meaning their XY locations. The Z is usually a mystery. A lot of times it's a mystery because the constructor putting in that water pipe cheats a little bit, and maybe instead of being at 4 feet, it's at 3.5 feet for a while and then back to 4 feet. Well, I see that quite a bit. So we didn't do that for them for this blush. And then there's just stuff we're not sure. We did some survey. We augmented that with some older data. So I wouldn't say the utilities are in their exact location, but at least they have an idea where they are now.
And how difficult would it be to, if you actually had the 3D data, that chill pipe actually goes into the building and runs throughout the building? So obviously that connection wasn't made either.
Right.
Which theoretically would be where we're trying to get to.
Right. The mindset of cities and universities, which are actually small cities, is we're starting to get 3D data given to us. For example, a Revit file with the Civil 3D site. I mean, they're getting all this information, and they're starting to figure out, well, I should use this for something. And Revit is a fantastic program, but it's a microscopic program, meaning it's good for designing a building. But I want that Revit model to go in my campus with all my other buildings. And I think that's the mindset. I'll build to some extent, somehow accurate to begin. I can't go hyperactive. I don't have the money to do so. But over time, like any database, it can become more robust. And a good example is I worked, again, for Intergraph in 1988, installed a GIS-based system at the city of Cortland. And back then, I had the clunky mainframe, and it took a week to get the software to work. But finally, I was so proud I got it working, and sat the systems manager down and showed him how awesome the software was. And his first question to me was, well, that's nice, but where's all the data to my city? And I'm like, the data? Well, that's up to you to build that data. But some slick salesman obviously misled him a little bit, shall we say. But my point being, you got to start somewhere. And again, I'll challenge all of you. Why did you go back? Why did we invest in CAD? It was incredibly expensive. You know, who does a return on investment on buying a license of Revit? Nobody. You got to have Revit if you want to compete and survive. And this will be the way for us as well. So again, we're probably early on the curve, but at some point, Ashton Kutcher is going to buy all of this stuff, and we'll need to buy with them.
And it feels like we're on the first side of that little jump.
Yeah.
Most of us haven't made that little leap over to the other side where they're climbing up. There was a chasm in your graphic.
Right, and that's the leap of faith right there, because, again, if things aren't robust, you have to figure them out. We've certainly at Bergman fallen on our face a few times because we didn't foresee certain challenges. When Revit first came out, there were certainly some huge shortcomings that we weren't aware of. We learned fast, though, that's for sure, as well. The network is incredibly slow here. This should have come up already. So maybe we'll let this run and you can just switch over. Oh, yeah, we can do that as well. That's going. So for all the thumb people out there, these newfangled devices that allow you to do all sorts of, this is a Google Nexus, but it could be an iPad, or if you want to come up later, I have it running on my phone as well. We can access this information on a mobile device where it really should be as well. Let me just call one up for you here. I'm just going to call up one here. I think in a perfect world, we have these, let's call it CityX has a 3D database, and then you have your Revit file that you want to put in and see it in the context that you want to see it. You should be able to link that information to the master database of the city so you get accurate views of it, or maybe you need to see the utilities that are going on to that site, but you want to do it out in the field somewhere, either at your desk or actually at the site. And it's hard to see, you can come down and play later, but I'm in an interactive model of a Walmart site, for example, in Albany. I just went off the earth as well. But same type of thing where you can access information mobile. And again, another one of those leap areas where there's still a lot of issues. And actually, this is probably a good example of that. Here we are waiting on information to come up. This is kind of my anti-technology side with everybody loves the cloud, but you are at the mercy of that cloud. I am at the cloud's mercy right now to see that information. And I still think the cloud has a ways to go before I'll be fully embraced in it. We did a recent survey of in upstate New York, top 50 firms on how they feel about the cloud, who is investing it, and not one of them has anything mission critical on the cloud yet. They do have cloud-based utilities out there. For example, email is a good example of that, but nothing mission critical yet. I think over time that'll improve as well, but again, early in this phase.
I'd like to bring you back to the data discussion.
Mm-hmm. Of course.
Can you share with us some of the challenges that you see, especially when you have data from so many different sources integrated together?
Correct.
When you see usually we see a school in the middle of the ocean, for example. Would you see that kind of issue? So that's the first question. What challenges did you see? Second one is, what is your advice in data updating? How frequent should we update this data and how to do so?
Well, from a thumb person, to answer your second question, it should be instant access all the time to the most recent data. That's obviously not realistic, but that's how the audience we need to address for certain. The challenges we've faced so far, and I'll pick again on Autodesk and Esri, when we first started this foray of using a college's GIS to build these worlds, the process of getting a Revit model into a GIS environment is challenging. Again, don't have that easy button app out there to do that. We have to, I call it the Colonel's 7 herbs and spices. We have a process that we follow to get that to work. At some point, we got to get rid of those herbs and spices and just have a flow. To me, those are issues that an Esri and Autodesk need to work out, and I think they are. I think the technology trend you're seeing is less proprietary, meaning I'm going to be very protective of my little universe. Those days are gone. You need to be open source. You got to work and collaborate together. In a real world, you have multiple software applications, not just one. So you need to collaborate better. And again, the challenge is sometimes those vendors don't want to talk, or they don't want to share source code information to allow you to achieve those goals. And that's certainly a frustrating thing. And again, our partner, University of Buffalo, we've had difficulty sometime integrating traffic data into some of these 3D models because we don't have access to that source code information to do so. Even when we do get that information, then somebody has to figure it out right now. I'm looking forward to the day that I can go to Best Buy and get that type of information as well. Yes?
It seems like the solution to all the different data sets, because you ask how often should you redo the data. A lot of data is being done all the time. There's a lot of different sources for the data. What we really need is we need a container that we can put this in and it's indexed. And I think that we need to be looking at maybe the database side, the database people, for the solution for indexing it. And then have it so that we can penetrate that container with either an Esri solution or a Bentley solution or an Autodesk solution. And the data will go in and find what it needs and be able to report on it. That way you have a window that you're familiar with, but the data can come from a lot of different sources.
Yeah, I agree, and that's certainly a challenge for us, and we don't want to have to write the one-off information to link that data properly. And we're just starting to find vendors out there that can help us. For example, Pembay is a solution provider that links facilities management data to GIS in a 3D environment, and because that's the way I'm thinking, 3D GIS FM now. I want it all. I want the outside, but I want the inside too. Again, fantastic volumes of great data in the facilities management side. How do I get to that information that I'm using on a macroscopic approach? If I'm thinking like a facilities manager, I need lots of information. As a facilities manager, I would like to be able to sit and have the architecture firm give me the Revit model, put it in my master campus model, run the utility analysis, run traffic data with it, and then see some other information as well. I want to see that. I don't want to do that information. I just want to have access to the information that the other good folks are doing out there. That to me is the ultimate goal.
Well, the databasing people have created a couple open solutions. I don't know if you've tried using Collada.
Mm-hmm. Yeah, I've used Collada as well.
Of course, FBX is quote unquote called an open database, but at the same time, it's pushed mostly by a single vendor, and other vendors don't want to adopt it. But Collada is supposed to be more vendor neutral.
Yeah, and that is true, and it goes back to, I think, the previous presentations about what are the procedurals that you should follow, what are the good guidelines for that, and that's that's that leap of faith gap again. We don't really have what is the trusted source to use. A lot of us are organically out there figuring stuff out. I think a lot of us are kind of shy to share that information because it gives a competitive advantage. But that's really what needs to happen. When you think CAD today, you're not worried about converting anything anymore. Even if you're bouncing between Bentley and Autodesk today, it's a pretty painless process. Back in the dark days, it was agony, but today you're not worried so much about that. I'll finish with this and let Kevin take over here. This is CityEngine, which is finally up, and we're running this over the cloud versus locally on my computer, again, to allow us to see an environment where we need to see it from. And this is a section of the city of Rochester, New York, that we can zip around. And it was created the same way as I mentioned before, the LiDAR information, aerial imagery. The buildings were all generated by a vendor for us and textured based off the aerial imagery. There's a lot of extra buildings added in here over time that are Microstation based, Revit based. There's some SketchUp models in here as well. Also that we can see it from where we want. But what the city wants to do is they want to convey their master plan to the public. So what I'll do right now is I'm going to turn on the master plan so you can see that on top of the existing city. And you can go back and forth to see. They have this is a code that comes with the program so that it's a lot easier to see what's new and planned with what's existing. Again, a really good feedback tool for the public so they can come in here. Again, since it's on the internet, you can do it from your home or wherever you need to do it from. Again, there's no special software, just went to a website, and that's what I really like about this product. Again, getting away from having to have software, and I'm really hitting all my thumb people with this one as well, where they want it.
Where can we find the URL for that?
As you can see, it's a long, complicated one. Actually, Terry's here. The city, if you go to esri.com, they have a CityEngine site, and there's many, many different demos in there that you can look at right now. There's also a lot of rules where you can find there within that website. If you want any of mine, just come see me afterwards, and I'll give you all the links you can handle.